I'm representing our group 11. These are my group members, Sandeep, Nikki and Trusha. We did our project to make a composite with a PLA and wood. So this is content. We are going to explain our object, reason of interest, and what applications process, and what difficulties we faced, and then our results and conclusion. So start with the objective. Our objective was to make a composite with the wood, like aesthetic quality of wood and the sustainability of PLA. So and our aim to make a like enhance our mechanical properties to make a durable product, and for that we use different woods to figure out which wood and PLA is more durable. And our reason of interest are sustainability, biodegradability. As we all know that PLA, polylactic acid, is biodegradable, and so it's a renewable polymer. So we can use it, and it's eco-friendly, and it doesn't have more bad effects on the environment. So we use it. So we use PLA and wood because these are renewable products, and we can use it. And as we all know that wood is known for strength, so we use wood for that and PLA so that we can make a good durable product. And innovation, our main product, it's our main reason, like innovation. So we can make a good innovative. So we can try a new product by rather than using traditional composites. And reducing carbon footprinting. As we know that the composites are fossil fuels, they have more carbon footprinting, but PLA is renewable product, renewable compound, and it produced from the cornstarch and everything. So there has less carbon footprinting, and it's less pollution. And cost consideration. So as we know that PLA and wood is not that much that costly, so that's the reason of interest that we use PLA, polylactic acid, and wood. These are the applications. For what we can use our composite 3D printing filaments. We can use composite to make a sustainable 3D printing filaments that can be used for the phototypes and everything, and construction materials. So we can use our filaments for the construction materials, wood panels and everything, and packaging. As we know that we are using plastic packaging products, like plastic containers. So it's a change for that. So we can use our composite to make the packaging products. And automatic components for automotives, we can use it as an interior design. So make the panels and interior text. And consumer goods. So and landscaping. For landscaping, we can use it outside for the decking and for the fence material. And it's like a weatherproof. So we can use it outside and inside both. And for the process, I would like to call Nikki.
So let's get into the process. Yeah, so we started with getting our wood samples. We got it from Walmart, and that were in a chips form, so we need to grind it. So we tried to grind it in analyzer lab, that already available grinder like Magic Bullet. But we tried that, but we were unsuccessful. So professor suggested us to just fill out that form, and we sent it to research lab. So they grind it for us, a very fine form, and then we started it. When we get it not that much fine, so we needed more fine, so we just grind it little bit more, and then we saved after that, and we got the 20 micron size for all these three types of wood. And after that we made the batch 70-30 ratio, like 70 PLA, 30 wood, and we made with the elder, cherry and maple wood. And in the manufacturing process, we did via two methods, like compression molding and extrusion method. So for compression molding, what we did, we just made the bent PLA sheets in compression molding, made the first one at the 165 temperature, and just the same way we made the second one at the same temperature. And what we did, just we take the already prepared one sheet and spread the wood particles on that along with the coupling agent, and we put the another prepared PLA sheet on top of that, and it's look like a sandwich like structure. And after that we made it in the compression molding machine and at the temperature of 185 degrees Celsius. And yeah, it turned out very good. Like it's look like a sandwich like structure. And if I talk about extrusion method, so we don't have a extruder operational, so we again called it to research lab, and they did prepare a sample for us, and it looked like a spaghetti. You can see this, like it was like look like a long spaghetti, thin strands, but we made it in a broke this into small parts to just add it into an injection molding machine. So what we did, like we prepared these two different methods, and we just used the injection molding machine to make the dog bone. For compression, we broke down that already prepared sheet into a smaller parts and add into an injection molding machine. So that way we made that dog bones. And extrusion, we did the same, like we took these small parts and added into an injection molding machine and made the dog bones. And for both the temperature was same at 175 degrees Celsius. After that, we also performed like tensile test, hardness test with the type A short durometer, and we also perform failure analysis that Sandeep will show the data after that. And what difficulties we face is, like I already told you, we don't have extruder available, so we were just waiting from the first day, like we will get the extruder. But after this study break, we got to know that we have the extruder, but it's not operational. So professor suggested us, like, so we can send them to a research lab, and they just made the sample. This was made the research lab, we didn't made it. So they made the sample and sent to us, and we just processed further. We plan to make like test the impact, but we don't have a jigs, so we didn't do that. Yeah, we also face challenge in like cleaning injection molding machine. Like if I talk about from starting of the term to end of the project, we spent like almost 7 to 9 hours in lab time during the just cleaning the injection molding machine. And yeah, professor also suggested during the meeting that it's good to use a cleaning agent. So we use cleaning agent, and that's helped us a lot to just clean this faster way. So, it's also hard to moisture management of wood. Sometimes like we were doing this process in injection compression machine, and it's like getting in problem in heating the wood. So we also face problem in material compatibility, as like some woods are compatible with the some kind of material and some not. So we also face that challenge, and we don't have a time, as we were just waiting for the extruders. We earlier planned to make a triplicate, but we could not do that because we don't have a time. So what we changed in the plan, like our whole plan was different. Like earlier we planned to like changing the ratio, like 50 to 70%, like 50 PLA 50 wood, 60 PLA 40 wood, and 70 PLA and 30 wood. But like we don't have an extruder, we have to send it to a research lab, and we were only allowed for only one ratio with 3 types of wood. So what we did, like we just go with the 70-30 ratio that is already available in the market. We did a 70 PLA 30 wood with 3 different types of wood. So we also made the batches, but that are available in the like physics lab, but we don't we just place it there because we don't use that. We also face a problem in using compression molding machine. Like we didn't plan to use that, as we only plan is to use extruder, but it was not, so we have to use that compression molding machine. And we also don't have plan to use 2 different methods. We just plan to use extrusion method, but like we were waiting and we have nothing to do, so we just go with that, like compression include 2 different methods, compression and extrusion. And also we removed one type of wood. Like earlier we have like 4 elder, cherry, maple and sawdust, but like we only allowed 3, so we just remove the sawdust. That is also change of plan. Now this data will be explained by Sudhir.
So how can we test that our sample is more strong or not from the bare PLA? So we have done the tensile test, and these are the results from there. So the stress is 1 point of pressure on the material when it breaks. So bare PLA becomes like ductile when it's lower temperature, and it becomes brittle if it is heated for at more temperature. So as group 7 has done it at 175 in the compression mode, it became ductile, and we have done it at 185, so it became brittle. So at that point, when the strain is lower and the stress is higher, that material is more stronger. So as we can see that cherry wood has the best in both. This is the extruder one, and this is the compression mold results. So we tried to make to keep an analysis comparison, but it didn't happen because the strain is very low, as can be seen, like 0.407. So it didn't happen. So we have just made the graph. So here also the cherry wood has like lowest strain compared to others, and in stress also compared to other wood types, it has more stress. So based on that results, we have concluded that cherry wood is the best in both of the cases. You can use, but I would suggest to use the compression mode because it's more cost efficient, because extruder is more costlier than the compression molding. After that, we have done the hardness test to check how hard is the material with combined. So there PLA has 9.3, and other materials we have done the compression molding one and the extruder ones. So in both cases, the cherry would have more hardness than bare PLA. So for the failure analysis, I would like to call Trusha.
Thank you, Sandeep. Hello everyone, I hope we are doing well. So let's understand about the failure analysis. Why we are doing failure analysis? What's the reason behind it? So the reason behind doing a failure analysis is to know about the center point of the fracture of a particular object or a material. So if we know about the failure analysis, we can save time, we can save cost of the money, and many more things. So as you can see the three figures, the first indicating the maple, we can see that there is not a uniform fibers, and they are in a rough situation. Looking towards elder, as you can see there is a huge gap or difference between the fibers. However, coming to the cherry, we can see they are not uniform, but they are close to the uniformity, so they are far better than these two. Let's come to the main point of our project, that is the conclusion. So as we can say that on the basis of hardness test, we got the results that the cherry and PLA composite demonstrate a superior property. Conversely, if when we done with the extruded machine, we get to know about that cherry and maple with PLA. It play have a favorable characteristics. So what suggestions and further steps we would like to give to the next people? So the first thing is available of extruded machine. As our group member already explained that, like we face a lot of challenges without, because of we don't have availability of machine, so we face a lot of challenges. So I suggest to next people to please make sure you have extruded machine. The second thing is the cleaning agent. That is also explained by a group member that we spend hour and hour, in cleaning machine. So make sure you have a cleaning agent which make it more easier for you, and of course it is effortless. The third thing is the coupling agent. Well, coupling agent works magic for us because we tried many things, to bind a material in a better way, but we failed to do that. However, after a few times, our professor suggested us to use the coupling agent, and that works magic for us. And we know that there are lots of advantages of coupling agents, such as it can retain a moisture, it helps to prevent different type of environmental effects, and many more things. The fourth thing is the processing optimization. So what is the processing optimization? So it is a process in a statical way from which we can have to follow the rituals, like not the rituals, but we can follow the initial steps to the last steps by following the proper procedure. So this helps in saving a cost, saving a time, and many more things. The last thing is use of ISO impact test. Unfortunately, we didn't got much time to use of ISO impact test, but I suggest next people to do that. So it will help you to know about the hardnesses of not hardnesses but a kind of resistance and
much more strong material. You can get to know about much more strong material of the resistance. So thank you for having your time.
So we use the 70% PLA and 30% wood. Can you repeat? Because
It's not audible.
yeah, as it is like covered in gold like PLA, it has more percentage of PLA, so it covers totally the wood. So it is not like that much prone to that.
That's why I told like it can use outside also, so it's weather resistant because we are using PLA with it.
Your main conclusion was about the hardness of the material. Why is important the hardness? For which application, for example?
So if we are like making a table or any like furniture, so it should be like hard and it should be durable to use it. So if it is not hard, then it can be easily broke. So that's why it is important. Any other questions?
So you used mean stress and mean strain.
Yep.
Could you have shown the data of Young's modulus or something like that?
Yeah, we would have, but we didn't have that much time because we got our extruded samples on the last 2 weeks. So we have done like made the dog bones and done the tensile test based on that. That's why we didn't have that much time.
Were you able to determine if the differences in stress and hardness were significantly different?
Yeah, because in compression molding, the material is like not eventually spread, so it was not proper. Also in the tensile test, the sample should be in the round cylindrical shape, but it was in the square and it slips out from the ribs, so it is not like 100% sure about that. So it depends.
Can you bring your tables back up?